All right, so we're going to take a break from the algebra side of geometry for 2 days, or maybe just one day, and we're going to talk about conditional statements, which I have been alluding to for a little while with our if-then statements. So now we're just going to make this a little bit more formal. So basically, if-then statements have a hypothesis, the first part that comes after the if, and a conclusion, the part after then, just like in science. And sometimes the statement is true and sometimes it's false. So we're going to talk about when that would be and also how to manipulate these statements. First thing to know, really know, is that the if and the then, they don't change, they don't move. They're always in those positions, locked. The hypothesis and conclusion can rotate and do things around them, but the if and the then stay the same. So, what is the hypothesis of if I am cold, then I wear a sweatshirt? Well, the hypothesis comes after if, so I am cold is the hypothesis. Listen carefully. I am cold is the hypothesis. If I am cold is not. Just I am cold. With that in mind, what is the conclusion? I wear a sweatshirt. And as far as true or false, the truth value of the statement, you just need to think about if there are any cases where it's not true. Okay? So what I mean by that is if you can find even one time that this statement could possibly be false, then the entire statement is considered false. So if I am cold, then I wear a sweatshirt. That would be false for me because sometimes I'm cold and I just don't have a sweatshirt with me. What I just did was give you a counterexample. Okay? A counterexample is what you can use to prove a conditional statement true or false. So sometimes I'm cold and I don't have a sweatshirt. That is a counterexample for if I am cold, then I wear a sweatshirt. Can you think of any other counterexamples? Okay. There should be a whole bunch of them, so it's kind of up to you for that. So let's see how this relates a little bit more clearly to geometry stuff. So let's think about this one. If two angles are vertical, we've done this before, then the angles are congruent. So we know that's true because vertical angles are always congruent. We have the hypothesis and the conclusion. And there are no counterexamples for that statement because it's always true. But let's look at how we can manipulate this statement. And these are the parts that get tricky. So we have three ways that we could manipulate them. One is called the converse, which we have talked about. And I just want to hop back for a second and fill in one part that I just skipped over a little bit. Often we use the letter P to represent hypothesis and Q for conclusion and an arrow. So if P, then Q. That's one way to write it. Okay? And that ties in right here because for the converse, you're switching the hypothesis and conclusion. So this is going to be if Q, then P. Okay? The converse switches. I'm going to use a different pen, like an actual pen instead of a marker. Maybe. Okay. The converse switches the hypothesis and the conclusion. Okay? And we've already decided that our original statement is true. If two angles are vertical, then the angles are congruent. It's true. So does that hold up for the converse? Remember that if and then stay in the same place. And we're going to move the hypothesis and conclusion around. So if angles are congruent, then they are vertical. And you can see, you can kind of change up the wording a little bit to make it comfortable. If angles are congruent, then they are vertical. All right. So we want to decide if this is true or false. Can you think of any times when angles are congruent, but they're not vertical? The first one that pops into my head is isosceles triangles. The base angles are congruent. So because I can think of even one example, this entire statement is false. The converse is false. The next one is called the inverse. Okay? The inverse negates the hypothesis and conclusion. We use this little symbol also for negate in geometry. So not P, then not Q. So the inverse negates the hypothesis and conclusion. So again, if and then stay in the same spot. They're stuck. But now we're going to go back to our original and make it negative. So if angles are not vertical, keep that in mind, then they are not congruent. So think about that. If two angles are not vertical, then they are not congruent. This implies that the only way for angles to be congruent is for them to be vertical, right? If they're not vertical, there's no way they are congruent. Well, again, those base angles of an isosceles triangle, those are not vertical angles, but they are congruent. And so I've proven this false. And last, we have contrapositive. The contrapositive does both things. It switches and negates. So not Q, then not P. Switch and negate. So let's think about this one. Again, if is stuck, and then is stuck, and now we need to take our original, switch them, and make them negative. So if angles are not congruent, then they are not vertical. If angles are not congruent, then they are not vertical. True or false? Well, if they're not congruent, they certainly cannot be vertical. So this is true. Now I want you to notice a pattern here. The original statement that we had and the contrapositive, those have the same truth value. And the converse and the inverse have the same truth value. That is awesome because it can get really confusing with all the knots in there. So this is always true, okay? Converse and inverse, original and contrapositive. They are logically equivalent, which means if one is true, the other is true. If one is false, the other is false. Is it possible for all of them to be true or all of them to be false? Yes. But always converse and inverse are the same, and original and contrapositive are the same. All right. Now, one case that we've talked about where you can use it in both directions, the inverse or the converse and the original, is the Pythagorean theorem. If a squared plus b squared equals c squared, then it is a right triangle. Yes, that's what we use to prove that something is a right triangle. If it is a right triangle, then a squared plus b squared equals c squared. Yes, that's when we use the Pythagorean theorem. All right, hopefully that's enough for you to complete the activity. Good luck and have fun. Trying to find my mouse on my screen. There it is.